So in this video, we're going to talk about templates in C++ and how we can create a template object. So there's lots of cases where we would want to do this. So if we're writing, for example, in a collection, we don't want to write a specific collection for each type that we may want to store in the collection. We just want to have one collection that'll handle any type. So the way we're going to do that is with a template. So we say template class T, which tells C++ that T is going to be some type. It's a type parameter for the class. So I'm going to call this class two things, and it's going to store two things. Thing one and thing two. And then I'm going to have a constructor. And we'll pass it a reference to two things. And we'll initialize those. And that's really all we need to do for our constructor. So let's write a accessor and mutator method. And that shouldn't change anything, so it'll be const. That's going to return thing one. And then our setter, it's going to take a parameter and set thing one equal to whatever that is. And for two, we're just going to rename them. Let's create some things. So I can create two things, a two things object that holds ints. I'll call it num. I can also create a two things object that holds strings. I'll call that strings, and it will hold CSC and 220. I guess I should write a print function as well. Now keep in mind, whatever type you do, even though in theory this could be any type, you're going to run into a problem if you have a type that can't do this operation, if it doesn't have a overloaded cout or overloaded stream injection operator. But string and it both have that, so we should be okay. So here's two things. We'll say nums print, and we'll say strings print. And let's go ahead and test our code. So it looks like I called it thing2 there. Looks like I didn't close my class. And I have a colon, not a semicolon there. So if I run, you can see that I get my output. I need to clean it up a little bit, I think. But you can tell that at least it works. So now let's take a look at the accessors. say strings thing1 or thing2. Looks like I have too many parentheses, so we'll get rid of those. And if we compile and then run, you can see we get, that's not good. So you'll notice we're missing that character there. So now we're getting just basically junk for that initializer. It worked for our int because it happened to be the right kind. But yeah, now that looks a lot better. Again, I'm missing my end of line. So now let's test our setters, or mutators, I should say. So let's say nums set 2 to be -11, and strings set 1, or let's do test set 2 there too, because we'll change it to 240. So just to make sure we're testing both, we'll go ahead and change that to set 1. And then we can copy this print code that we did above. So we can compile and run, and notice we have our initial values from the initialization. Here's the accessor testing. Here's the mutator, and you can see that they both work. Now, we've done this. There's no reason we can't have another type. And I'm going to make thing2 type 2. I'm also going to change the order. And so everywhere I'm referencing a type for T2, I'm going to make it that type. So now I need to say, here's an int and an int. Here's a string and a string. So now there's 2 types. And if I compile this, this works. But then I can also do an int and a string. So now let's do 421 tk. And so now down here, as we need to call it, so now let's print that out. And let's also do the accessors. So we're actually finding bugs. Notice, and I should have caught this before, get2 should be doing thing2, set2 should be doing set2, so that's good. I'm glad I caught that. I guess I should have checked my output and noticed that, yeah, that didn't actually get set. It set thing1. So I should have caught that, but I did now. So, and now if I run this, notice everything else works before, but notice now I have one that has a mixed number and a string. And again, I have two types that I'm defining, so those can be the same, they can be different. It just depends on what it is that I want. So let me put an extra end of line character there just to clean up the output a little bit. So that's under mutators. So I think we can clean that up as well. Yeah, so I think our output now looks a little nicer. So there is an example of templates in C++.